All right, so our goal for this lesson is to be able to convert between exponential and log form, to be able to evaluate logs, and to use the change of base formula. So as we're working through this lesson, make sure you're thinking about when do we use the change of base formula. So first of all, let's start out with what is a log? What is a logarithm? So a logarithm, or we shorten it to log, is another way of writing an exponent. So logarithmic form is this right here, and we read it as log base b because it's in that subscript, it's below, of a equals x. So that's just a form that you're going to need to know, log base b of a equals x. So like if I look down here for example 1, this would read log base 3 of 9 equals 2. And so I can rewrite that logarithmic form into exponential form. So the exponential form is b to the x equals a, which we've seen before. And so let's go ahead and look at where the pieces come from when we go from logarithmic form to exponential form. So let's just think about the words that we use, log base b. And when I look over here, b is the base. So that makes sense. Log base b of a equals x. So the x is the exponent in the exponential form, and the a is what that expression is equal to. So these are two things that you're going to need to memorize. You're going to need to memorize that log base b of a equals x is the same as b to the x equals a. So go ahead and make sure you have that written down and that makes sense in your head as far as which pieces go with which in the different forms. All right, so we're going to start with just basic converting. So that's the first part of our objective, is to be able to convert from exponential to log form and then from log form to exponential form. So we're going to start with log form to exponential form. So here is log base 3 of 9 equals 2. So when I look up here, log base 3, so that becomes my base, of 9, that becomes what it's equal to, and then the 2 is the exponent. So let's go ahead and write that out. And when I think about it, 3 to the second is 9. So I did that correctly. So go ahead and pause the video, and I'd like you to try number 2 and number 3 on your own. So hopefully with those you were able to come up with that 6 to the third equals 216, which if I multiply 6 times 6 is 36, times another 6 would be 216, so that makes sense. And then 7 to the 0 equals 1, and remember from Algebra 1 that anything to the 0 power is 1. All right, so let's look at number 4. It's a little bit different because I have log base negative 2 of 16 equals 4. So go ahead and pause the video, and I still want you to write it out, and then we'll talk about why it's a little bit different. All right, so hopefully you were able to write negative 2 to the fourth equals 16. However, I'm going to guess some of you did not think to put it in parentheses because it's the value negative 2 being raised to the fourth power. It is not just negative and then 2 to the fourth. So let's look at why this is true. All right, so that means negative 2 times negative 2 times negative 2 times negative 2, which if I multiply 4 negatives together, I'm going to be positive, and 2 times 2 times 2 times 2 is 16. Now, if I had left it without the parentheses, the answer would end up being negative 16, which is not 16, because I would take the negative of 2 to the fourth, and 2 to the fourth itself is positive 16. So those parentheses are really important. All right, go ahead and try number 5 and number 6. Pause the video. All right, so in number 5, you should have gotten 4 to the negative 2 equals 1/16. And if we remember, that negative exponent moves it to the denominator, and the negative goes away. So in the denominator, I'm going to have 4 to the second, which is 16. And then the numerator, I'm just going to have 1. And then for number 6, I have 9 to the 3/2 equals 27. And we're going to talk more later about what an exponent that's a fraction, what that means. But this is about the process of being able to just rewrite from that log form. So go ahead and pause the video and identify any areas that you're confused on that you want to talk about tomorrow. All right, so for this one, we're going to work backwards. We're going to go from exponential form into that log form. So go ahead and remind yourself of what the different pieces, where they come from, and we're going to walk through this first example together. All right, so just a reminder, log base b of a equals x is the same as b to the x equals a. So let's go ahead and take number 7, which is 14 to the second equals 196. So I know that the base is the same. So when I look at this, the base is 14. So I know I'm going to have log base 14. And when I look at this, what it equals to becomes what the log base 14 of what it's equal to. In this case, it's going to be 196. And then my exponent becomes what my log is going to be equal to. And so I've got log base 14 of 196 equals 2. And I can always check it by 14 to the second equals 196. So that is correct. All right, go ahead and pause the video, and I'd like you to try to write out from exponential form to log form the remaining 5 problems. All right, so hopefully you were able to get these numbers. So go ahead and check through the remaining problems and mark any that you have questions about, and we can talk about those when we get together. So go ahead and pause the video. All right, before we get started in the second part of our objective, evaluating logarithms, I do want you to be aware of this idea of a common log. So a logarithm with base 10 is called a common log, and it can be written without a base. So log base 10 of x can also be written as just log of x. I don't need that base 10 in there because this is the common log. All right, so when I'm thinking about evaluating logarithms, so as I move into solving these log to find the values, I have some guiding questions I can use. So the first one is, how can I rewrite the log into exponential form? So it's going to help me solve it. And then there's 2 ways to think about it. Some of them are kind of obvious, and so we can use our intuition, and others are a little trickier. So if we can use our intuition, what value for x would make the equation true? Or how can I rewrite the basis to have a common value, pulling on what we did yesterday? So let's look at this first one, number 13. So the first thing, I see log base 7 of 49, and I need to evaluate it to find what it's equal to. So first of all, how can I rewrite the log into exponential form? So I went ahead and set it equal to x, and I rewrote it as 7 to the x equals 49 because that's the equivalent version in exponential form. So then I can either practically think through this and say, okay, 7 raised to what power is 49? So obviously the answer is that x would have to be 2. Now, if I didn't know that off the top of my head, I could use the second question, how can I rewrite the basis to have a common value? And I would recognize that 7 is the base, so I could rewrite 49 as 7 to the second. And now that I have common bases, I can just set those equations equal to each other and say x equals 2. In these cases, for the simpler ones, I don't need to necessarily solve an equation, but if I need to, it's there. So x equals 2. All right, so let's go to number 14. So log base 3 of 27, and I need to evaluate it. So we're going to set it equal to set it equal to x. All right, so how can I rewrite the log in exponential form? So go ahead and pause the video and rewrite that log into exponential form. So 3 to the x equals 27. So I can either use my practical thinking to solve it, or I can use those equations. So 3 to the x equals 27. Well, I know 3 times 3 is 9, times 3 is 27. So that would make x is 3. However, if I'm struggling a little bit with those logs, I can write that equation to have a common base. So obviously 3 would be the base. And then rewriting 27 with a base of 3 would put it 3 to the third. And now I have a simple same base, so x equals 3. All right, let's look at 15. So log of 100. So in this case, I don't see a base. So I'm going to go up here and I'm going to recall that this is a common base. So when there is no base written in, it's automatically a 10. I'm going to rewrite that as log base 10 of 100 equals x. So how can I rewrite the log into exponential form? So 10 to the x equals 100. So I can either practically think about it, 10 raised to what power will get me 100, or I can rewrite it so they have the same base and solve that equation. So either way I think about it, x is going to be 2. All right, so log base 12 of 1, I need to evaluate it. So I'm going to rewrite it into that exponential form. So I have 12 to the x equals 1. And when I think about it, the only time that I get 1 when I raise a number to an exponent is if that exponent is 0. Anything to the 0 power is going to be 1, so x is 0. All right, I'd like you to pause the video and I'd like you to try the remaining 4 problems on your own. See if you can find what the logarithmic expression is equal to. All right, so as you worked through those examples, hopefully you were able to come up with the following answers for 17, 18, 19, and 20. If you were, go ahead and skip to the next portion of this lesson. If not, I will walk you through what I did. So in 17, I know that it's 2 to the x equals 64. So I thought 2 raised how many times will give me 64? So I got 6. In 18, 3 to the x equals 243. So how many times can I raise 3 to a power and get 243? And that's 5. And then 19, this included a fraction. So 9 to the x equaled 1 over 81. So since the value went to the denominator, I knew it had to be a negative exponent, and so I thought 9 to the what gives me 81, well 2, and to make it be in the denominator, it's going to be negative 2. And then for 20, 64 to the x equals 4. Well, the fact that 64 is getting smaller means it needs that fraction for an exponent. So I turned them into both having base 4. And so 64 with base 4 is going to be 3. And I brought that x down. So 4 to the 3x equals 4 to the first. And so now I have, since they have the same base, I just have a simple equation, 3x equals 1. Divide both sides by 3, and x is 1/3. Sometimes it's not always easy to see exactly what exponent value would make this log true. So we have what's called the change of base formula. And the change of base formula says that log base b of a is the same as the log of a divided by the log of b. So when I have a problem like example 21, the log base 16 of 64, and I'm going to evaluate it. Well, 16 to the what power is 64? That's 16 times 16 is never going to be 64. So I need a different method than just evaluating it using my knowledge of exponents. So I can use the change of base formula. And over here it says choose the base 10 because there is a calculator button for it. You will need your calculators for these using the change of base formula because we're going to get some decimals. And anytime that you do get a decimal, I want you to round it to 4 decimal places. That's just going to be our standard. If it doesn't tell you explicitly, always go to 4 decimal places. All right, so let's look at 21. Log base 16 of 64. I'm going to rewrite it using the change of base formula. And when I do that, I get log of 64 over the log of 16. And if you notice, we didn't use any base here, so we're going back to that idea that if there isn't a base written in, we're using base 10. And we want to do that specifically because that's what our calculator can do. We have a button on there. So go ahead and in your calculator, I'd like you to type this in. Be very careful that it might be helpful to put parentheses around log 64 divided by parentheses log of 16. Otherwise, your calculator might try to do something else using the order of operations. So I'm going to use the button that's next to the 7 on my TI-83 that says LOG. And when I do, I end up with it equals 1.5. And I can always check my answer by taking 16 to the 1.5 power. And when I type that in, I get 64. So what I'd like you to do is using the change of base formula, I'd like you to try these 5 remaining problems and remember to round to 4 decimal places. Go ahead and pause the video now. All right, so look over these answers. compare them to yours, the setup and both the answer. And if you didn't get that and you can't figure out why, make sure you mark it and we will talk about it when we discuss this lesson. All right, before we wrap up this lesson, I want you to think through our 4 objectives today. So the first objective was to convert from log form to exponential form, then to convert from exponential form to log form, then evaluating logs just basic using our knowledge of exponents, and then evaluating logs using the change of base formula. So I want you to look at your work for each of those, and I want you to come up with a common mistake that you think students make when they do each of these problems. Go ahead and pause the video so you can do these reflections. And the last thing I want you to do is, as of right now, with your understanding so far, I want you to come up with your summary of the different parts of this topic. And then how would you rate your understanding of this topic? So from a scale of 0 to 3, how do you feel about this topic so far?